Geolocation is pretty important. Like Uber is the highest valued private tech company in the world with a valuation of over 100 billion. And the core feature of that app is real-time geolocation. In today's video, we'll build some of the most important features that go into an app like Uber, such as device GPS tracking and real-time geolocation queries to a cloud database. And we'll do it all in under 200 lines of code using tools like Flutter, Google Maps, and Firestore. If you're new here, like and subscribe, and I highly recommend following along with the source code on Fireship.io. And a huge shout out to Darshan Goda. Not only did he write most of the code for this video, but he's also the author of the GeoFlutterfire library that powers the geoqueries that you'll see in this video. Let's start by taking a closer look at the app. You'll notice it's a full screen Google map, and then we have a slider down here in the left corner and a button in the right corner. In Flutter, we can arrange this layout very simply in a stack. When we move the slider to the right, it will zoom out the camera and also increase the range of our geoquery. So the app allows you to find all of the safe points within a certain radius of a center point. And more often than not, that center point will be the actual user's device location via GPS. And the button down here on the right allows us to add a new geopoint to Firestore based on the device's current location. But the really awesome thing is that we can update the markers on the map by reacting to events in the database. So you can see as this blue dot moves and we add additional geopoints, they show up on the map instantly. That means you could have multiple users listening to the same stream of geolocation data and they would all get the same results in the UI. Similar to the Uber app, how everybody can see the same drivers moving around in real time. Now let's go ahead and get started. The first thing you'll need to do is have Flutterfire installed. You can refer to the official documentation, or I cover all the steps in the Google OAuth Flutter video. When you create a Firebase project, it also gives you a GCP project where you can obtain a Google Maps API key. Once you have the API enabled, go ahead and copy that API key, and then we'll bring it into our Flutter project. Now let's take a look at our dependencies. We have Firebase Core and Cloud Firestore. We're bringing in RxStart because we have some relatively complex stream management to deal with. And then our geolocation dependencies include GeoFlutterfire, Location, and Google Maps Flutter. And keep in mind that the Google Maps Flutter package is very new, so there may be breaking changes in the near future, so just a heads up. The next thing we'll do is go into the Android app source directory and find the Android manifest. If you want to track the user's location, you'll need to request permission to do so, which we can do with this tag. And then we'll go down here to the application and add some metadata for the Google Maps API with the API key that we obtained earlier. Then for iOS, we'll go into the runner appdelegate.m file and add our API key there as well. In the same directory, you'll find the info.plist. We need to add the following key value pairs to obtain permission on the iOS device for the user's location. Now we're ready for the fun part of building the actual app. You'll notice I've commented out the dependencies that we don't need yet. I will uncomment these as they become necessary. And right now we only need Google Maps. The app itself just starts with a material scaffold. And then we have a stateful widget down here that will encapsulate all of our state and all of our logic. So we can actually just come up here and make the body of the scaffold this fire map widget. If you want a map that's responsive, perfectly centered, and takes up the entire screen, I would recommend using a stack. This will allow us to set the map on the bottom, and then we can overlay different controls as needed. So we can start by adding the Google Map widget as the first widget in the stack. It requires an initial camera position, which is a latitude and longitude point for the actual map to be centered on. We pass the coordinates into the target option, and you'll also want to set the zoom level here as well. At this point, if you run the app, you should have a full screen map that looks similar to this. Now the map itself has its own lifecycle hook called onMapCreated. We'll set up a handler for that lifecycle event, and the important thing that we do here is set up the controller on this widget. The map controller is super important because it allows you to interact with the map by setting markers on it, zooming to a different position, as well as a bunch of other things. So those are the most important setup options that you'll have for your map, but you can also do other things here too, like if you want to track the user's location, you'll set My Location Enabled to true. You can change the map type, for example, if you want to show the satellite imagery. And the last thing we'll do for this map is enable camera tracking, so we can always get the current center point of the camera. Now that we have a basic map set up, let's add a control to it. We'll add a button to the bottom right that can add a new marker based on the camera's current position. We'll go back up to our stack in the widget tree and add a new positioned widget. We can define the bottom and right properties to put it in the bottom right corner, and then we'll define its child as a flat button that has an icon, and when this button is pressed, it will trigger the add marker event handler. Now we need to actually define this method. The first thing we'll do inside of it is define the marker itself. The first thing we'll need to give it is a position, and we can do that by looking at the map controller's camera position. And that will give us a latitude and longitude to place the marker itself on the map. We can also customize the icon here, and we can also add information to the info window text. and that will be displayed when the user clicks on the marker. And finally, to add this marker to the map, we just call the map controller add marker with this marker options object. Now we should be able to pan around the map, and when we click the button, it should add a marker to the center. The next thing we'll do is use the Flutter location plugin to track the user's actual position. This is very easy, and we can get the user's location either as a future or as a stream. We'll go up here to the top of our stateful widget and set up a new instance of location. Now we'll write a method called animateToUser that will animate the camera to the user's current location. This will be an async function, and then we can get the location by just calling await location get location. And you can use onLocationChange if you want to listen to it as a real-time stream. Now let's animate the camera to this user's position. For that, we can use the map controller, call animateCamera, and then we'll update it with a new camera position. Now we have a way to programmatically control where the camera is animated to. And you can see our current position is this little blue dot in the middle of the screen. At this point, we have a map, the user's location, and the next phase is to save locations in the Firestore database. You can see here we have a locations collection, and you'll notice that every document in this collection has a position field that has a geohash and a geopoint. GeoFlutterFire will create this entire data structure for you, including the geohash value. I'm not going to go into how geohashes work in this video, but it's basically just an algorithm that allows you to encode a bounding box on the surface of a sphere. In this case, we're talking about planet Earth, and this is important because we need this string to be able to query Firestore for everything within a certain radius. Now we'll go back to the top of our application and import the remaining dependencies. Then notice in the stateful widget, I'm setting up a value for Firestore and also for the GeoFire client. Before we can query anything, we first need to save some geolocation data in the database. For that, I'm creating an addGeoPoint method, and this is going to add a document to Firestore, which will always return a future of a document reference. The actual value for the geopoint will be the user's current location. So first we'll get the location with our location service, and then we'll set up a geopoint based on that latitude and longitude. A GeoFire point is just a special data structure that's primarily responsible for calculating that geohash, but can also do other things like calculate distances between points. The next step is to make a reference to the collection that has our geolocation data, and then we'll define the position as the point data. And that's really all it takes to add a geopoint to Firestore for the user's current location. Let's go up to our button and replace the add marker with the add geopoint method. You can see I have Firestore set up here with an empty database, and then as I click this button, it's adding new documents to the database in real time. Currently, you'll notice that all these geopoints are the same. That's because it's based on the device location, which currently isn't changing. But here's a little tip if you're working on Android specifically. You can go into the emulator settings and send your own custom GPS locations to the device. When you push send, you'll see the blue dot move around the screen to the new location. And if we add another geopoint, this time you'll see it's a different geohash and a different set of coordinates. Now that we have a way to get data into the database, let's query it and then add markers to the map reactively. The query itself is based on a radius, and we want to be able to change that radius. So we're defining it as an Rx behavior subject, which is basically an observable that we can push new values to and always has the concept of a current value. It's an extremely powerful data structure for dealing with state management both on the web and in Flutter. The next value is our actual geoquery, which is a stream of the documents from the Firestore database. And then we'll set up another property for the subscription. This is definitely the type of subscription that can result in a memory leak, so you'll want to make sure to cancel it when this widget is disposed. Now we'll go into our stack and we'll add a slider so the user has a way to actually change the radius value. The slider widget is built into Flutter material, and it's pretty straightforward. We set a min and max value and then divide that by a certain number of segments. We can always grab the current value from our behavior subject by just calling value on it. So whenever setState is called on the stateful widget, it will get the current value from that radius subject. And whenever the user slides, it will trigger this onChanged event, which we can then use to update the query. But the query is the very last thing I want to show you. First, I want to show you what we do once we have the actual documents from the database. Anytime there's a change, Firestore will emit the entire list of documents, so we can loop over them and update the markers on the map. This marker code is almost identical to what I showed you earlier. The only difference is we're taking the geolocation data from the Firestore document and using that for the position of the marker. And also, GeoFlutterFire will give us the actual distance of this position from the query center point. We can use that data as the info window text to show the user how far they are from a given point in kilometers. The next step is to set up the initial query and start listening to it. We'll start by getting the user's current location, and then we'll make a reference to the location's data in Firestore. To make this query, we need to start from a center point. For that, we'll set up a GeoFire point based on this user's location. Now, our actual subscription is dependent on two different streams. First, we need to listen to the radius value, and then we want to use that to query the database and listen to the value of those documents in real time. This is where I really like to use RxDart because we can call switch map on the radius and then switch to an observable of the documents in the database. And to make that query, we just call the geofire collection within, and then we pass in the center point, the radius that we want to search, and then the property of the document that contains the geolocation data. And I also recommend using strict mode here, which will ensure that only points within the radius are included in the query. Otherwise, you might get some additional documents in the query that go beyond the radius because of the way geohashes are square-shaped. And lastly, we call listen on the stream, and then we'll run our update markers method that we defined earlier. The next step is to update the query when the user slides the slider around. Now, just to make this a little more polished, I created a map of different zoom values so we can zoom out when the user goes to a higher radius. That part is optional, but the important thing is that you call setState here, and then add a new value to the radius behavior subject. So we already have that set up on our slider. The last thing we have to do is call start query when our map is created. And it's also probably a good idea to come down here and override the dispose method and cancel that subscription when this widget is destroyed. And that's all there is to it. We should now have a demo that allows us to change the radius and update that query in response to that change. And it's pretty crazy to think that we just built a real-time geolocation app in about 10 minutes that runs on both iOS and Android. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe. And if you have any questions, leave me a comment below or reach out on Slack. Thanks for watching, and I will talk to you soon.